Hello, what's up everybody? We're changing it up a little bit. We're starting a little earlier today. This is Pulse Motor Mayhem with Papa Bale. And we've got some awesome stuff to show you today. We got the magnetic identifier paper film. We get a... Alright, so we got that. And we pull it out, and you can see that field kind of grow. It's the light color around the dark color. Just kind of puffs out. And that darker color in the center. It's really nifty. I think it's cool. And what's really cool right now is we've got the counter rotating pulse motor going here, and we got options with the magnets. So we got the big magnets, big squares, some art going on there. We're slowly but surely picking up. It's looking better around here. There's so much to do though. So much to do. Alright. But I was going to keep just this pile of transistors here. I don't know which ones of them, if any of them are broken. But those are my MPNs. I got this little MPN in here right now. But it's pretty powerful. I mean, I hope everything's still connected alright. Let's check it out. Then we got this 120-degree cube magnet, neodymium, not bad. Oh yeah, that light is on. Okay. Let's check this. That was kind of perma on. It's alright. It runs so smooth with this one that I'm really impressed with it. Even though the coils are wedge shaped, the magnetic field, you know, and it saturates less quickly than with the big magnets. It's got a nice little chirp to it. This is a 24-volt setup. So it's two batteries running series, two 12-volt setups running series. Everything's on the stator, and the stator is on the bottom, except for the reed switch, which is out to the side. And it wants to move. Heck yeah. I like it when it works out that way. Okay, so that's a nice smooth ride right there. So we're going to reattach the reed switch. And that's the only way I can stop it right now. I want to build a remote control into it and place it somewhere on the stator. Probably right here in the breadboard, if it's just going to be the concept. Just put it right in there. Because you got to have the remote control, and then you got to have the receiver. Huh. Yeah, I didn't like that. For some reason, it wasn't blinking. still working pretty good. Huh. Because if the reed switch gets stuck, I gotta pop the transistor. There we go. Yep, we gotta pop that. I can hear that hissing. I don't think I mean, it's gonna be really hot, so. It's got a heat sink. But yeah, that's really, really hot. It is a 12-volt system. But it doesn't have enough kick to move at 12 volts. So I'm going to try something else. I mean, it'll move, but it doesn't move. After you put 24 in, yeah, it's like, whoops, should have done that the whole time kind of feeling. But, I like it. We're gonna stick with the smaller magnets though, I think, for right now. That's a way better transistor. Oh, baby. I gotta secure the wiring here better than it is. It's gonna fly right off. Just a little dab. Rest on that. For some reason, I think because of the higher voltage, sometimes the transistor stays closed. It's like the voltage is forcing it open. You know what I mean by open, right? Not the circuit, but the transistor. I think it's sweet. I don't mind messing with it a little bit. Get it to run right. I have a fat resistor on here, right here. And that's from the base of the reed switch, or the negative of the reed switch. One end of the reed switch is going into the resistor, and that's going into the base of the transistor. I think that's the way you're supposed to do it. Yeah, the thing is, I bought all these heat sinks, right? That, but the M-size screws they sent with the heat sinks don't fit the transistors, any of them, if they're not long enough. And running basically a 12-volt transistor without a heat sink on 24 volts, yeah, it's not pretty. Okay. And I think, I don't know for sure, but they got these little washers in here. Do these even fit? Not these ones. Those ones will fit though. Yeah, okay, I see now. Let me grab one of the, a fresh one of those. It's the one we were just using, and it's still good, it's just hot. Oh, it is the same type, just a different build as the big ones over here. It's, yeah, let me get in the light real quick. 2SC3320. I think. But I'm blind as a bat, so. I don't know if I need that. I mean, this one has one, but the screw is like so much longer. Looks like I need it. And then my screwdriver are over there. See, this, that cannot be right when this one is that much. It's like almost twice the length of this. And then they want me to put that washer in there too? It's like, that's not gonna work. But we'll try it. And if not, we'll just unscrew, take the screw out of that. Because this heat sink is a little bit more broad. Might be the same amount of material though, it's just a different shape. And that'd be a hard on the mic B. Just, you know, it's a different shape, so. So we're gonna swap out this little one. It still works. We're gonna put a big one in there. The big one was in there, but you know, it went sideways. Alright, let's show the comparison of the screws. That's why I gotta do that, because it's like twice the length. I don't understand. Well, okay, that one's in. Let's see if we can screw this one in. I don't think it's gonna go, but we'll try it without the washer. Yeah, it doesn't even go all the way through the transistor. I gotta get different screws. All this stuff will work if I just get longer screws. Alright, so now we got a heat sink on that. I bought these two really nice SG generator combo circuits from K Energy, and they're really, really nice. They're like so nice that I mean, I have the exact idea of what I want to do with them. They're going to be, but I have to get all the materials to build it. I just started out with the circuitry, and yeah, I got the two batteries that I'm gonna need, and you know, all the pieces are coming together slowly but surely. That won't work. So it's a little different. I got it secured now on the bottom of the table and the top, so it should be able to go a little faster. I really don't know about the 24 volts. I know it performs well, but I mean the resistor's not enough. This little resistor that we got over here, the big one, and I don't know how hot is too hot, but that definitely is getting hot, so I don't like letting that run very long. I tried hooking it up parallel using these type of connectors, so I could use the breadboard and the transistor, and it didn't work out the way I wanted it to, so I'll work on that. That'll be 12 volts across with however many amps. This little bad boy is cool. It's axial flux, DC powered, battery powered. It's 24 volts, two 12-volt battery packs in series. We're running on like a 3SC5200 transistor. And occasionally we got a 2SC3320, which runs okay. Not as good, but okay. It's definitely a different class. You can see it, that there's definitely more to one than there is to the other. They both work okay. They both burn out just as quick. They both get hot like just as fast. Yeah, it's not that bad. So we got our magnetic field testing strip here. You got your, like right on top of the magnets is dark, but the real strong magnetic field is around the magnet, right? When you pull it out, it expands. As it gets farther from the center, it expands. It's kind of hard to just, it's not really hard to understand. The universe does the same thing as a magnetic field does. In my opinion, as it expands, all that, you gotta like, I don't know, it's more solid than it appears to be. Right on. It's like, I don't have to go there because I'm already there kind of thing. What do I mean by that? It's a good question. It's kind of like, I can demonstrate it with like these two objects. We'll just use the two transistors, right? Same space, same time. You get a collision, right? Same space, same time. Different space, same time. So right here, right here. Boom, boom. So it occupies the same space, but at a different time. All right? And then the other way around, well, I think they both demonstrate themselves in the same fashion, but you can't have same place, same time, because that's the rule. That's why you have the rule. But essentially, everything is together. You can, it's just, that's why time is there, because if time wasn't there, you'd get a collision. With everything. Everything would collide. Right? I mean, just in that demonstration. And I don't know if that demonstration is accurate, but it seems pretty solid in my mind. I mean, as a physical demonstration of what's going on with time and space. Not a mathematical demonstration by any means. It's like banging two He-Man figures together, or a Skeletor and a He-Man figure together. When they occupy the same place at the same time, they're going to clash. Boom. It's cool though. I just see the similarity between, like, say, space and its expansion and the green paper, and the farther you get away from the magnets, the wider and more translucent that field becomes. If you can see that, I mean, you get the really acute when you're up close, and then as you get farther and farther away, it gets wider and wider and more translucent and less opaque. If you get what I mean. So there's a center, and we're moving away from it. Right? I mean, that's what we know, pretty much. But we're learning new stuff every day, and I'm finding that out too. That what we knew 20 years ago, you can kind of throw it away, or you can, like, use it as a framework for what we know today. And I don't know anything. Some of that stuff you just gotta throw out the window completely, because it's just like, you know, this is a toy. I like to play with this thing. Yeah, I'm definitely gonna need this. But I mean, its concept is you're supposed to be able to travel in time with the gyro, counter rotator. Supposed to be able to move that fast. Okay, that's what it's supposed to do. But it's just a toy. And, you know, the original design was a ship, you know, and it held a person inside of it. And the person was supposed to be sort of centered around the person inside. But this isn't going to house a person. No way. And it's never going to go that fast, you know? But it thrills me, man. Blows me away. This is awesome. I can't get enough of this. Now, if I just let it run for a little bit, I got this little meter over here. See how fast we can get it going. About 500 RPMs right now. But that bottom part is spinning a lot faster than it usually is. That's weird. Okay, 504. I think that's actually, it feels good to me, man. That's nice and safe. It's doing what it's supposed to do. We're gonna try the bigger magnets though. please leave a comment. I'll check them out later. I am not engaged. I apologize. If you wanted to engage, I truly apologize. Something happened with the proximity there. Something that I don't like. So I can't like clip it in the same spot anymore. It might be the arm is moving finally all together. In which case I'd have to put it back. But yeah, I would say that oh, I can hear that. It's like humming, dude. Like a really high hum too, like. Wait, not that one. Oh yeah, wow, there's a lot of heat coming off of that transistor. So what I'm gonna do is I am gonna just run the one 12-volt battery on this next run. We'll see what we can get out of that. And then I'm actually gonna charge the batteries. Okay, so it's right here. I don't think that's gonna work. Take that off. This comes on. This comes off. This comes up over here. It's so cool that I can like do this in my head with it looking the way it is and have it come out smelling like a rose. I hope that works. I mean, it looks like a piece because I have all the glue, but there are still some wires that I need to secure, and I don't know. I don't think zip ties will work. Alright, so now we just got the one battery hooked up. I think, honestly, hopefully, this is a good one. This will run without a heat sink at 12. I can't take it off the other one right now, but I need that screw. That's kind of why. This is 12 volts, or probably 11, 10 and a half volts right now. And it's still pretty good. It's not as good, I don't think, but take a look at this one. Alright. And then, you know, the farther and farther everything gets away from each other, it will consistently lose influence on each other as well. So, you know, as you know, when it starts off real close, the reflective light is even influential. Still influential, you know, our moon, it can illuminate. You can't, it's not so you can just see it, but it'll actually light stuff up. Reflective light is going to be real important. Do we have a way to like harness that light? Yet the moonlight, like really different, you know, different tech. That would be sweet. That would be sweet. Then you wouldn't have to wait for the sun. Let's put the blue rotor on here. See if it'll. I mean, the positioning is all different. I'm probably going to have to hold it. But this is pretty cool, I think. I tried running 6 magnets in the cube one, and the fields are too close together for it to function properly. So it'll work as like a regular motor, but there's no real force there. Just seeing if there's like a place that I can clip it down. Yeah, that light stays on. If it's staying on, that means the fields are too close together for it to function properly. It's a good indicator that that's what's going on. And I can't pry those magnets out of there. I'm going to have to saw it open and build another one. Maybe I just hammer them out, you know, but I'm probably going to end up having to change the shape of those holes. Which is okay. It's alright. I got some green hyper filament that I'm really good looking forward to using. So I think it would work best probably at 18 volts, honestly. Like 2 9-volt batteries in series. That would be nice for this. I don't think that would get too hot. Yeah, I think the switch is getting burnt. was a lot, I feel like it was a lot more sensitive the first time I used it. And I think it has a lot to do with how I have to stop it. So if we can identify a way to make like a receiver coil, what are we trying to do with it? What we're trying to like turn that on and off the reed switch with the remote. That's what we're trying to do. Or the transistor, whichever way we got to do it. We're trying to put an on-off switch that's remote controlled on there. I gotta read up on that, how to do that, like what coils are necessary, and if I can even make one small enough to fit in there. I should be able to. Some kind of material, I mean, they're all over the place. An RC or a boat or anything like that should be able to have something inside of it that I could use. Or I could make my own if I knew how to do it. That'd be sweet. Because if all you need is like, well, I think it's like frequency, and when it's ranged, it's based on frequency, yeah? Or maybe ohms too, but definitely frequency, and they gotta match up. And then you can send a signal through the air. I mean, that's what I gathered from the one video that I watched on it. I mean, I've seen one of these DIY remote control. Not one of these, but the remote control, and actually how to build it. And it was a little big for this, but I got the concept from there. So that's neat. That's 12 volts. Like I say, 24 is a little high, but it's so fun to see it move. Alright, let me show you some of this stuff over here. Got another counter rotating pulse motor right there on the table. Alright, this is one of my first circuit. It's a whole motor diagram basically. It's direct. It's got a magnetic induction switch or a reed switch. Starts with a P. It's a reed switch basically encased in metal like we have here. And then you got your cores, your multi-filer coils. I made this a long time ago, but your basic drive has got your north-facing 32 gauge, 5,000 turns, and the drive circuit is in this way in series, so it goes in, 120 degrees, a 120 degree circuit, and then each one of these is a drive circuit, or I mean a generator circuit, and it's in series as well, and it all has cores. But the other two, so you got a single file coil here, and a 4-filer 32 gauge coils in the other 120 slots. So coil, and then this is N52 magnets that are attached to the rotor or the circles. And this is how you time it, like dead on. It's supposed to be dead on timing pretty much. You could shift the drive maybe up to 21.5 degrees, something like that. but it's a 9 magnet rotor design, and you use a DC buck converter or a transformer, DC to DC transformer. And let's see, you got like a 10 volt, 9.6 minimum out of the power supply to run the transformer. And then this is typically because of the the high gauge, the 32 gauge, you can run a lot of voltage through this, and you need to run a lot of voltage through it for it to operate the way you want it to. So it all kind of works out. Yeah, I'll get back to them. I also paint. I do a little bit of painting every now and then. And this is, just like a pathway going around a cave with a boulder in front of it. And you got some footprints in front of the cave, like, 2 people meeting in front of this cave. And then you've got your either your swamp or your kind of waves crashing against the shore here. It's also could be a desert. There were conflicting reports on the location. So you got your night sky. It's pretty neat. I think it's cool. You got your Joshua trees. Let's move on to the next one. And again, we've got a 9 magnet situation here. This is a 369 pulse motor generator. It's virtually the same design, except it's a 3-phase motor with 2 generator circuits and 1 drive circuit. 3-phase motor generator. So you still got your 1 drive phase at 120, but you got 2 separate generator phases. So they're generating, and then you can combine them or have them do separate things, but they're pretty powerful when you separate them or put them together. It's pretty neat design. Got that one. They're all run on a reed switch. All these designs are for a reed switch. This one's a little hodgepodge of different wire gauges and lengths. They're all written down here and in order. Some of them are air coils, some of them are not. I mean, it's total hodgepodge. I call it the ant funnel. All north-facing magnets, 4-magnet rotor, DC power supply, 100 volts out of the transformer. Reed switch again, but it's in series, so it goes in here, out, around, and then the reed switch is 180 from well, I don't even know if that's right. It looks to be 180 from the power supply in this regard, but you find this is where it goes, like in between. It's at the cardinal directions, because this is up and down, north, south, so west. Put it on the west side if you're looking down at it. Just line it up like that, and it should work up to the tune of like 1500, 1600 RPMs with just a reed switch. I mean, when you first look at this one, you're like, it could be watercolor or something, but that's all acrylic. That's pretty nice. I love this one, actually. I paint really fast, so it's not like the most realistic stuff in the universe, but I think it's pretty cool. Alright. So here again is another diagram of the 6-magnet monopolar amp funnel pulse motor AC version. It starts out with DC, but what I call the DC version, all the coils are connected with a rectifier diode. That's what I call the DC version. Because I believe after the DC electricity in this gets past the first coil, it begins to oscillate. So I call this the AC version. It's pretty cool. I think it's neat. Oh yeah. Haha. This little bad boy is like a triangle, in a triangle, and a triangle, and a triangle, and it's spinning. I did this one like 13, 14 years ago. One of my first oil paintings. It's pretty sweet. Among other things that I've made in my exploration with magnets is a north-north magnet. So all these are facing north. You flip it over, they're all facing north. What I found out is that the south field you get two north-facing fields, but they're half the strength of, say, stacking them together instead of stacking them in opposition. So it's got less lift or less attraction. But it will work as if you need to. I've had at least 2 situations where I actually needed to use it. Alright, so right now my girlfriend is trying to get a hold of me, and she should just come over like she said she was going to do, and unless she can't, and then she's just got to wait, because unfortunately I film with my phone. I'm not going to commingle the things right now. So that's actually not that hot. I mean, it is hot, but not that hot. And now we got the heat sink. So that should be all right. And it's all, I got it stacked up on some bearings, flanges, the rotor, because doing it with a maglev wouldn't have worked. It's too precise of a measurement to clear the transistor and the coils and be in proximity for it to work decently. So proximity is key. The magnet's got to be close enough to the coils for there to be an interaction, which is pretty easy. These are 20 gauge and 32 gauge bifilar parallel wrapped coils in a wedge shape. So they go all the way to the axle in the middle here, and they stick all the way out. So they're wedge shaped all the way out to the end. And you notice how the magnets are just on the end. They cover more area with this big one right here. So the saturation factor is really low, I would assume. But it happens. You know, it just takes a little bit more time. The magnets are literally covering like 1/3 of the coils. I don't know, honestly, if that's truly important, but I know the proximity to the coils is key. It's like key because you got about a 3/4 of a centimeter clearance over the transistor right now. So I could probably, honestly, remove the one bearing from the very top and drop it that far and it would still work. As a matter of fact, I want to try that. Rest it right on that flange and it wants to come off. So this is proximity realized. That's what we're going to call this experiment. Oh man. Or we'll call it close proximity. Close proximity experiment. So we've now lowered the rotor an additional, I believe it's, I want to say 3/8, maybe less, maybe it's 1/8. I'm not sure, I'm not going to measure it right now. It's really small. Now let me see, it's really, really, really close. If this thing is true and flat, but now, see the reed switch is in a little bit different placement now. We'll give it some time. We'll see what happens. It is closer to the coils, but like I said, the armature may be a different. I might need to make a new arm or move it somehow. I love it. And another thing that I've kind of discovered just from building these is that every motor like such, whether it be axial or radial, if you make it so the stator can spin freely, it will want to spin in the opposite direction that the rotor's going in automatically. It just happens. It's part of how it works. I found also that using a reed switch has been the most promising for me. I tried trigger coils, they don't really work that well. My hypothesis is that since you can spin the rotor both ways with the trigger coil, you don't get the opposition force that you do from using, say, a reed switch, which is a definite direction. I don't know if that's the case, it just feels like that's kind of what's going on. It might just be because the pulse is that much less, but I don't think so. Now, ideally, if you can make the weight the same on both, and that's really the key, is having the weight and the friction ratio be the same on both the stator and the rotor. They will spin at roughly the same speed. I'm going to put that back on, and we're going to do, if you can remember how that performed, I kind of got an idea. We're going to run another exam here. And now I raised it up like one bearing size. We'll see if the proximity to the magnets or the proximity to the reed switch is more important with this rotor. I don't know, I'd say that's obvious to me. Well, not really anymore. It must have just, maybe some graphite powder. But I think that the proximity to the reed switch in this case is more important. But I honestly, I think well, I don't know. I know that the blinking is going pretty well here. But alright, we're going to do one more test after this. We're going to switch a few of these around. Alright, so for you, those that weren't here in the beginning, I ran this on a 24 volts. And I'm going to do that one more time. Heat sink is going to be real important here. And we're loaded up on that, so we're good. And after this, I'm going to charge the batteries. I have a specific charger. These are nickel metal halide batteries. And make sure that's not too high. Oh, that's really, really cutting it close. This is 24 volts. But that transistor is going to get hot, really hot. So this is why I need a remote control. It goes any faster than this, it's gonna, it's gonna hurt me if I try and stop it. I think that's so sweet. But that 24 volt run is pretty key, but I can hear it like squeaking, like a high pitch hiss, kinda. I've actually had that be a lot hotter than it is right now. So that's pretty good. Coils are good. Alright, so about like a cap dump from the 32 gauge strand into the 20 gauge drive with all the proper diodes and whatever. But where did I put that little thing? I got a 50 volt 2.7 microfarad capacitor. I got a whole like 6-pack of those. And I was thinking about putting those in the breadboard here. Hooking the 32 gauge strand to them and to the ground. Well, I don't know if it's grounded necessarily, but yeah, we hook up those 32 gauge coils into those caps, and we're pumping 50 volts pretty often like that. I don't even know if it'll work because probably need less than 50 volts because the 32 gauge, these are loosely wrapped. I mean, they're okay. They're okay, but they're, compared to what I would do on a machine, they're pretty loose. I'll try something different, maybe putting a 1/4 inch hole or something through the center and try and use a machine. Like a certain size hole through the center. Then I can hook it up to the machine to begin with. That might work. Make a little bit tighter wrap, but 32 gauge strands don't even generate like 5 volts. I mean, I would literally be putting 5 volts back into the system, and each time that it spins around it would be less and less volts. So it's like every single time you have loss. So is it even worth doing just to see what would happen? I don't know. I messed around with it a little bit and it did exactly what I thought it would do. Pretty much absolutely nothing. Absolutely nothing. Absolutely nothing. It spins pretty much the same amount of time after the fact with the 32 gauge as without the 32 gauge hooked up. Now you can run it in series and you can do 20, 32, 20, 32, 20, 32, but then you gotta have like 63 volts going into this thing just for it to run effectively. But you get less heat that way, I think, honestly. With that much resistance, you should be getting more heat. I don't understand how it works that way. I mean, my coils are always cold. Coils never get hot. I don't know why. Probably because it runs pretty smoothly. Most of the time, anyway, it runs pretty smooth. Yeah, I was honestly thinking about maybe even running all 20s and then the 32s after the fact in series. So like, in my opinion, there's different ways you can split that up. And I don't think that one would run at all, honestly. I think the alternating 2032, 2032 and doing one coil at a time would work. I don't think doing the 20 all the way around and then 32 all the way around would work at all. Don't think it'll work at all. As a matter of fact, I've tried it before on several different motors with the bifilar coils, and it doesn't really work at all. So this goes around, I think it goes about 500 RPMs with this one on. We'll get a tach reading this time. So how do you guys like the new orientation? I'm kind of working with different stuff. Different angle on the table. I'm bringing like my other hobbies in. For Hondo, 430. I think they're moving at about the same speed, honestly. It's about 500, 490. Wow, I'm getting so many different readings. 491. So those batteries need to be charged up for sure. Got about, like I said, 500 RPMs. I believe the bottom might be going 200, 250. Oh, remote control. I need a, maybe even just to reverse engineer an RC vehicle or something. Just take it apart and get the pieces I need. No, that's pretty solid. Right, so we'll back it out a little bit. We're going to put the big rotor on, and then we're going to charge it up. Oh, come on now. Cheap clamps are the best. The best. I think this one goes faster than the other one. Got so much more magnetic energy going on here. Alright, so it's this number divided by 3, okay? 26, 27 divided by 3, so 900. Three 31.91, 32. So that's like 1100 right there. I didn't need to do that, but I know that transistor is freaking hot right now. I don't want to break any more of my stuff unnecessarily. I know that's an oxymoron because of what you just seen, but that was freaking cool. Okay, that was 1000. And then to make sure when the voltage is that high on the circuitry, you got to take the transistor all the way out because it'll stay linked up. It just does. I don't know why. But anyway, that ringing is gone now. I'm going to take the transistor out. Sounds like just a really high frequency. Maybe it just might be my ears, honestly. Man, that was sweet. So I'll see if the memory is good on the attack over here. We'll see what the last reading said. 3219. So not quite 3333, but it was going in that direction way faster than this one. Way faster. And I believe it's because the magnetic field encompasses, there's more interaction. There's more. It's like when you bite into a Jolly Rancher or a piece of candy, and it's hard candy, and you break it into a million pieces. When those million pieces touch your tongue, more surface area of that candy is touching your tongue, so you get a really big burst of flavor. And that's what's happening with these magnets, because more of the magnetic energy is touching the surface area of the coil. It's a really big coil, in my opinion. You know, it's like that, and it's a wedge shape. So I mean, these are square magnets, but it works. I tried this one, and the reed switch is just straight up wrong, and it's a 6-inch rotor. There's like nothing we can do about it, really. I could even do that, and it's not gonna help. But I could make a different arm for it, because I think it's got to be out and probably a little lower. Because it's actually a pretty nice rotor. Alright. So I got a whole lot of heat sinks like this. And the M-size screws that they sent me are like half the distance too short to work with any transistor, basically. See, when you pop it back in, everything's good, everything's reset, things aren't touching or stuck together. When a reed switch and the transistor gets stuck, like perma on, dude, I had a power supply and 21 amps were running through it, and I was like, oh my god, why isn't there a fire starting? I turned it all off, and luckily a fire didn't start. But 21 amps, man, everything was fried. Nothing worked after that. And it wasn't very many volts. It just, everything was, the current was free to flow. That's what a cross wire, depending on what the wire is, will do. And I just think it's just the basic concept of the bottom pushing off the top. You don't need to sandwich it. And you could, though, and you could have one rotor spinning one way and the other spinning the other way, and then the one in the middle. I don't know if it would spin at all, but we could find out. We could use this one and this one, and I could put this one on the bottom. We could try that. That is so cool right there, man. That is freaking fast. Holy cow. $3,000 divided by 3. 1,000 RPMs right there. $24 volts. $32. $34. $35. Yeah, we gotta pull that out of there, or that'll go forever. Haha. Just until the batteries run out. Wow, that was sweet. That was the best ride yet. But I hear that hum again, that high squeaking hum. It's not like a pulse motor hum, it's way faster than that. It's not like the squeaking of a trigger coil, it's not like that. It's probably just my ears giving out on me, honestly. That's what it sounds like. I think a major accomplishment is the north-north magnet right here. It's, both sides are north facing. I used to do some experiments with magnets like that, homemade toroidic magnets. So you got your paper, you put it on there, you got your dark, and you got your light around the dark, which signifies your magnetic field. And you pull it away and it expands. It gets wider, but it gets more translucent. It gets less opaque. It gets less dense as it expands, because everything is expanding. Everything's getting farther apart. But it's really a solid. All this, everything in between, dark matter is filling in that space. Dark energy. All that stuff is at work too. And I'm talking about the magnetic field in regards to everything and how it works in the universe and whatnot. So if you imagine the Big Bang or whatever, it starts and it's real close and then it expands, right? Starts, it's real dense, it's real close, and then it expands as you get farther away. Same concept, basically. And yeah, I mean, if it's manipulatable, you can manipulate it. Mathematically, you could probably manipulate everything that you can discover mathematically. It's simple. You change the numbers. Are you lying when you change the numbers? No, you're just doing something totally different and unintended from when you started. That's all you're really doing. And that happens a lot with me. Even if I plan it out, I end up probably more than likely deviating from the plan, or adapting the plan so that it makes more sense. I mean, the first variation of this had one battery and a bunch of connectors, wires wrapped around like this, like fire hoses just stacked up on top of this thing. I narrowed it down to one. I got everything connected with these little clips. So I think this is consolidated. This is, you know, as a prototype, it's pretty consolidated. You know, with some tweezers maybe, and some smaller stuff. You know, we could make a top out of it, and we could spin it. I have a different variation of this entirely. The coils go on. It's attached. The stator is attached to the shaft. Okay, so you have to spin the shaft in order to turn the stator. You get what I'm saying? It's just a totally different build. And there's a commutator on it. And that's how the power gets distributed. So it's totally different. I mean, the only thing that allows it to work with the commutator is the fact that you can spin the shaft. Or the commutator that I built for it. I would grab it right now, but it's in the other room. I'll probably go get it real fast. Okay, so this is it, and it's on a maglev, and it's got the little clips. Commutators right here. We got super glue every other and up and down, so it kind of goes like this. And then we'd have a brush on the maglev hooked up, you know, so that it works. You gotta believe me, it works. I'm gonna do it over again though. Make a better design with the commutator, but using the same idea. And it spins like this. So totally different, same idea of the, you know, spinning in the opposite directions and everything, but totally different design basically. Yeah, I got these really nifty SGs. I'm just, you know, I gotta get the copper to build the coils for the motor. I think it's gonna be a 16 gauge. Two 16 gauge coils, about 666 turns a piece, bifilar with 30 gauge. And I was going to run each one of those coils. Actually, the original design was 250 turns of 16 gauge, but that's a little hot, you know, that's a little much. So I made them longer. Put a little bit more resistance on it. 32. 33. 34. 35. So 35.91 divided by 5. No, divided by 3. My fault. Haha. It's like 1,300 RPMs, man. That's fresh, man. I'm not complaining. Anybody who's complaining about that wants to seriously mess with time. I'm not down. I have no desire to do that. You know, 3,000 RPMs is probably as fast as you want one of these things to go. And I'm planning on, you know, making a smaller version of this one, so you can make it as a top and just spin it, and it should work. Have all the coils and everything else inside the top. And yeah, I mean, like a dreidel, freaking dreidel that can spin like that. That would be awesome. So I mean, another design that we could do, I mean, I think that my buddy Brian didn't think that the bottom was going to spin without a solid force to push against. I mean, we're blowing that theory out of the water like nothing. This will definitely spin both ways without a solid thing to bounce off of. It's bouncing off each other, it's bouncing off itself. But I think, honestly, if we put the magnets the right way, and we can put one on the bottom and they'll all spin kind of different directions. I don't know about the bottom one though. I think it will sink unless we. Luckily, all the coils are rolled the same way, the same direction, roughly the same amount of turns. I wound them by hand, so didn't use a drill or anything. I just wound them by hand, and they work pretty good for hand wound coils, man. They work really nicely, and they're pretty taut. I mean, they're not machine wound, but they're pretty nice. So they're all wound counterclockwise from start to finish. The start is at the tip of all of them. The end is at the end here. 32 gauge strand and a 20 gauge strand. So they're bifilar coils. 45% imbued iron PLA, so they have cores of 45% iron. I had to stack bearings physically to get the exact height that I wanted, like enough clearance for the transistor. And the coils, so it will spin freely, both of them will spin freely, no friction. And these are the things that I considered when building this, like as I built it. And then I'm like, I gotta get rid of all the wires. So I did what I had to do that. Everything's linked together. I can run these in parallel, or I like running them in series. This is a series circuit right here that I'm using. Just the 20 gauge strand is hooked up right now. But you know, this breadboard is big enough to hold 3 of these transistors. we could definitely do that. Again, let me reiterate on the fact that I have many different, like I have at least 2 hobbies. I won't say many hobbies. I like to build pulse motors and I like to paint. This is an acrylic painting of, it's a stream. And you can either consider this part the stream, it's running, or you consider this the stream, and this is like the, you know, the steps on the side, or the bubbling brook, the grass. You know, you could use your freaking imagination with this. I like it. Watered down acrylic. Really neat. Alright, here we got Tryst by the Sea. You got your 2 footprints here. You got your cave. You got your stone roll to the side. You got your swamp or your sea. You got your Joshua trees. A sea of Joshua trees. You got your night sky, kind of twilight sky. You got your multi-leveled, you know, dwelling or tomb or cave right here. You can tell that this has been shaped. Okay? You got your path coming through the trees here to come alongside to the cave. This used to be watercolored, like blue, but my buddy convinced me it was a desert by the Dead Sea. And so I changed it to like a desert color on a twilight. But I mean, it's conflicting location. Maybe we're talking about different events, you know? It's really neat, I think. And I got some schematics here. These are drawings. Very simple. There's no transistors involved with this. Okay, it's just you got your... Alright, here's the one with the legend. You got your N52 neodymium magnet, that's the circle, okay? You got your core, that's the straight line. You got your wire, that's the squiggly line. Okay, you got your single file drive coil with a reed switch. It's 32 gauge at 5K turns. Okay, and then you got a 4-filer 32 gauge M52 at 50 turns a pop for your 120s. Okay, so pickup coils, 4-filer, 32 gauge, 50 turns. 9.6 volts into the transformer, 35 volts out. It's a buck boost converter, but it's definitely run like a transformer. I mean, you screw it to turn it up. You know, it's got a little, you literally stick a screwdriver in there. It's pretty cool. So this thing runs on 9.6 volts, but you need this buck boost converter. It'll transform that 9.6 into 135 volts. And you got your drive 120. And then you got your other 6 coils of various gauges. It doesn't necessarily specify the gauge because I believe it's up to you. It's a generator circuit, so if you want more amps, then you make it thicker wire. If you want more, I think 26 would be really good for a generator, or maybe even 30 or 28, somewhere in there. Even 32, but this drive is with 32 gauge. You got an amp funnel circuit right here. Goes like this. It's the DC version. So this is a list of the different gauges and the sizes of each coil. There's 8 coils. We got 14 gauge at 90 turns, 18 gauge at 180 turns, 20 gauge at 725 turns, 32 gauge at 3,333 turns, 26 gauge at 3,174 turns, 28 gauge at 1,111 turns, 32 gauge at the same rate at 3,333 turns, and then a reed switch in it. With all that resistance with the 32 gauge, there is no problems with the reed switch whatsoever. As long as you put that on the end and not at the beginning of your circuit. Now this one, actually I wanted to show you this one. I call it the 369 pulse motor generator. So there's 9 coils, 9 magnets. It's a 3-phase thing here. You got one drive phase, which goes from here to here to here. It's hooked up like so. And each one of these coils is actually, you know, it's filled out here. We got 32 gauge 4-filer for these ones, 32 gauge 3.5 inch drive. I'm not sure what that means. It's a bigger drive coil, I'm pretty sure, than the other 32 gauge 4-filer ones. Alright, and it's 32 gauge. It's a 32 gauge motor, it looks like, and generator. But each generator coil has an iron core. I think a revised version is that all the coils have an iron core. But in this one, there's 2 generator phases. So there's two 120-degree circuits which you can run separately or in parallel, or in series. But they are separate. So I consider that 2 more phases, or poles, or whatever you want to call it. Each 120-degree section here I would call a pole. Or a phase. I'm not sure which one it is exactly. Probably a phase. But each one of those circuits is timed to hit at the same time with the magnets. So it's 9 magnets. Each one of those 3 at any given time will hit at the same time. So that, just like this, all these hit at the same time. And that gives it enough force to move. They're timed with the electromagnets on the stator. It's, you know, and you can offset it up to 20, 21 degrees. Try and get that the magnetic field. You know, when you get it to a certain distance, it's kind of farther away from the magnet. You know, it expands as it gets farther away. Cool. Now you can see some purple in there. Let's see how much damage I just did. I think it looks cooler, honestly. Now my brother thinks maybe I could run it on a tangent. Like, clip it to the pole like that. Alright, that's kind of okay. I think it looks cool. got bored there. Alright, so we got 72 bar neodymium magnets on each side of this thing. They're at 5 degrees. And it fits perfectly. You can't squeeze another one in there, man. There's just no room. So 5 degrees is what they're built at. Just those little discs. I think that's really neat. What's the point of them? What's the point of having one of, any of this stuff? It's scientific, you know? This is just a north-north. I didn't have any toroid magnets, so I built my own. It's a north-north toroid magnet. It's 6 inches in diameter. All right, so .26 gauge coil, single strand. I'd say this one is maybe 2,000 turns. It's getting hot in here. I'm gonna turn this on real quick. Might impair your ability to hear me. If you're already impaired, I apologize. I'm trying to speak as loud as I can with the camera being as far away as it is. Hopefully I'm doing an okay job. So this is when you're running out of batteries. This is what you do. Because these are basically lithium-ion batteries, you can't run an SG to charge them, or they'll blow up on you. They get too hot. If there's an SLA battery that's this small, I'm all for it. But I think I got the smallest one on the market, and it's pretty freaking huge. But if I'm wrong, that'd be awesome. If we could make this thing run like that, that'd be freaking cool. So yeah, like if you have a link of some kind that you can like post on the chat to an SLA that's sealed lead acid battery that's about that size, 12 volts, I'll get that. Like I said, man, if we can run the SG generator circuit on here, that would be sweet. Alright, let me turn this on real quick. Alright, we're charging at 2 amps. This is like a cap dump right here for DC battery charge. For 6 to 12 volt nickel metal, whatever it is, nickel metal halide battery pack. That's going to take a minute, a little bit of time, which also sucks. So I guess the ultimate goal is to get this to run in something the size of a top. It can be a larger top. Doesn't have to be this little tiny thing, but it has to be something smaller than this. And I propose that even if you're not riding in the middle of this thing, if it's going fast enough, it will mess with time space. Doesn't matter whether you're in it or not. That's essentially, well, it's charging and I'm trying to get it to go. It's essentially, yeah, I'll get back to that. So that's also like one of the things that I'm looking for right now is an SLA battery. This is the smallest one I could find, and this thing weighs like 8 pounds, man. It's freaking too much. But it's got 9 amp hours to it, 20 hours of good use right here. And I got 2 of those, but you can't like run it on this. This is way too heavy. Then I got these 2 12-volt battery packs, but you got to use this to charge them. So right there, it's like, make up your mind, people. Synergy, man. That's what we need here, synergy. Synergistic. Again, welcome to Papa Bale's Pulse Motor Mayhem. Sorry I haven't been engaging. Hopefully my moderators are here to help out. That would be so cool. If you're here, awesome. If not, that's cool too. I'm just going to keep going here. Yeah, I'm not going to do that. I'm going to charge this up. And now that I've started charging it, I should probably finish, because it is recommended that the batteries, if you're running them in series, are started with roughly the same capacitance and charge rate as each other. And that might not have anything to do with the actual amount of juice that's in the batteries, because they are the same battery pack. I think that's good enough. But we're going to give it a little bit more juice, so we're running at 12 volts. Then I got like this one right here. This one runs like a top. You can spin the shaft and it'll go. I'm thinking now, I'm really thinking, because we want that shaft to spin. Or maybe we don't. I don't know right now, honestly. I'll have to think about it more. We want to be able to spin it like a top, so I don't know if the shaft needs to spin or if it doesn't. Maybe it doesn't. Maybe we just have like, yeah, we'll see, like the casing or the stator hooked to the shaft. And when you spin the shaft, you spin the stator. And the rotor in the middle should go the opposite direction. And this is the fast charge rate. This is the 2 amp cap dump right here. It's 120 volt, 12 volt charger converter. It says do not charge lithium ion with these. Only charge. So these batteries might actually be chargeable. I don't know though. I don't know. I honestly heard that the SLA batteries are the only ones that work with like the DC circuit. But this charger won't work with lithium ion either. Only charge nickel metal halide and nickel carbon something, NICD or NINH battery packs. Now, I admit on a live stream earlier in the week here, I was speaking some broken Spanish, and I apologize. Back in elementary school, we learned Spanish. Me and my class, I virtually went through all elementary school with the same class. And there was, I don't know, man, we threw mama jokes back and forth and everything like that. And, I apologize if I insulted anybody with my broken Spanish. Truly sorry. I'm gonna stick to what I know from now on. Just language-wise, I don't want to insult anybody. So, I was thinking axial flux, air coils. These are 50 turns, roughly a piece. 2 around clockwise and the other 3 around counterclockwise. And they can be positioned like, say, like the Olympic symbol, something like that, as a stator. I think it'll work pretty good, man. It's a 22 gauge, that little section right there, and we're trying to move an aluminum rotor with that. I have a 2-channel signal generator, so that should actually that might actually work, be cool. Send different frequencies to the north and the south. We can mess around with that quite a bit. Sorry we resorted to charging the batteries, but obviously, as it's taken a while, we needed to do that. And just to show you how simple it is to run this, and charge it and reuse it, and no, man, this is a counter-rotating pulse motor, unless with infrared maybe I could take some readings, but I mean, I don't think that's really a thing. You can't clip a multimeter to this. There's no commutator. There's nothing you can do. I mean, it just spins and it looks pretty sometimes. You can get it spinning pretty fast. I do want to make a remote control so I can turn it off. Right? That's cool. So we'll put like a remote control system right here, and then have like the on-off switch in your hand. Hopefully we can get it so that it stays underneath the bottom or the top of this bearing right here, because that's how much clearance you have. The breadboard to the top of that bearing, and you want to be below that. So whatever coil or whatever needs to go in here has to be that small. I don't know exactly how to build it. Maybe I'll buy an RC car, take it apart. Maybe it's just an antenna. Who knows? I don't think that's how it works though. But I think what's going to happen is we're going to need like some caps, maybe a cap or two, a coil that's more or less, well, I'll just have to see how it's built. I think a really tiny gauge coil is going to have to go in there. And then we're going to have to sync frequency. I mean, if we're going to home make it, and then, I don't know. I'll get the car first and we'll see. We'll go from there. But yeah, man, being able to turn this off is turning into be a pretty key component. But the top one, like, you spin it, and the stator starts to spin, and you got your little reed switch in there, and you got your little coils in the middle, or coils on the outside, it doesn't really matter. You got your little permanent magnets in the middle there, maybe smaller than this. You got your little coils. Yeah, it'll all be really small, and it would probably work, honestly. You could get like, just like a little, even like put a solar panel on the top of the top, right? That can harness light bulb light, like a really sensitive one. And then you get, little tiny rechargeable batteries and you put them in there. You just spin it, man. I mean, for a really cynical mind, that would be terribly funny to just drop one of those in like a supermarket. Yeah, I don't know. I mean, if I can get a top to do that, that would be so sweet. But I mean, I have a trimmer. I mean, me being able to do something that compact would probably not happen. But it's in here now. It's just a design. It's in the head. They have to be like perfectly balanced with the weight and everything. And that would be something to like strive for, to make it perfectly balanced. Like this one, it'll shimmy once it gets going really fast, and I don't mind, because it's only going to go so fast, no matter what, because that's what I want. That's the way I want it to be. But these big ones especially, it gets going too fast, and somebody's gonna end up getting hurt, and I don't want that. And apparently it doesn't matter how you build it. If it gets going too fast, it's gonna melt. And that's just part of things going fast. So, I don't know. And there's probably materials out there that cost billions and billions of dollars, but what do I have to do with that? Nothing. Absolutely nothing. I mean, it'd be cool to get my hands on some of that stuff. Like graphene, I'm interested in that. I really want to have it be so you don't have to get 100 rotations to generate 20 volts. You can just generate it in one pass. That's the ideal right there. And it's just a concept. It's not necessarily 20 volts. That's not the important part. Okay, the important part is that you generate the same amount in one pass that you do in 100 passes with copper. That's the point. Does that exist? I don't know, but that would be really useful, don't you think? I'm pretty sure somewhere on some level that exists, and I'm pretty sure it's, you know, hooked up into a very high torque, very low speed motor. Because if you spin it at the same speed that you would spin the other one, you better have a, you know, like in current, you better have a path that's pretty freaking solid to follow. Because it's going to want to jump out of that path. And probably more than once along the way to wherever it's going. And that's when you get melted enamel, that's when you get, when the current wants to leave the path that it's set on, without there being another path for it to lead to, that's when you get stuff to blow out, that's when you get smoke, that's when you get that stuff, because the resistance is just too freaking much for the amount of current that you have. Even if it's like... Whew. Sorry, I had to answer that. She called me like 3 times. Yeah. So that's been a nice 2-hour stream. I think I got about another hour left in me. We're still charging at 2 amps for the 12-volt battery pack right here, and then we gotta clip the other one as well. But this will provide a full day of enjoyment if you like watching things spin. It's really easy to build. I mean, when I say really easy, I mean it's really, really complicated, and it took me virtually 2 years of compiling data and information to get everything that I needed, including a 3D printer, including iron-infused PLA to make the cores, including all the copper, including the knowledge of the breadboard, including, you know, some CAD information. You know, all that came together to build this. If you have a lot of all that stuff already, this will probably be pretty easy for you to do. If you're starting from scratch, not so much, man. It's probably going to take a while. I mean, if you know how to read a schematic, I don't do schematics, but I could draw a picture of this. I mean, there is one transistor. We're not going to put that in there right now. And it gets triggered from a reed switch, which is high frequency. You got to make sure you have a high frequency switch, or it'll be incompatible. That's, you know, airtight, you know, encased. This is a metal casing, but there's a glass tube in there with a reed switch in it. And this is an indicator light that's attached to that circuit, so when it gets connected, the light goes on. When the circuit is closed, the light is on. The circuit is open, the light is off. People ask me about that light all the time, and I'm like, it just shows you when it's closed. That's all it does. It has no other purpose. I think it's cool, man, to have that indicator that you know if it's working or not. Your reed switch, you know if it's blowing out or not. And I mean, you get that same indicator with the ionization in the reed switch that you can see through. It's the same principle. Because you don't get that ionization like the arcing type substance in the reed switch, it's not working. It's not functioning. Of like some kind. And I know that's not right. Because I know you can like set it up with resistors for that not to happen. Yeah, I'm getting tired of waiting around, so we'll call it good. You guys want to call it good? We'll call it good. And then we'll do the other side a little bit. Whew. Man, I feel great, but I feel old, man. It's hard to walk around for 3 hours, sitting at a desk, in a chair, and walking around, standing on your feet. Two way different things, man. I'd love to. As a matter of fact, I'm going to change this setup a little bit. I'm going to get a wide angle camera attached to the ceiling to give you the aerial view. I might have my phone working as well. And we'll get a couple of angles, different angle cameras going. And I'm going to set up a PC in the corner. So if I want to sit down, I can sit down, man. And that'd be great. And not have to like stop everything to do so. But I mean, it's still good to stand up for a while. I feel like I'm gaining strength slowly but surely. And it's all right. Sorry again. I apologize for not engaging with anybody. I can't do that right now. I hope my moderators are around. If they're not, I apologize again. Noah, Peter Halifax. And I hope my explanation of what's going on tonight is available to you. Anyway, this is a reed switch pulsed. Run on this transistor. Let's see what number it is. Looks like a 2SC5200 maybe. M.P.H.Jr transistor. The base is hooked up to the reed switch. Pretty simple. And I mean, the kind of rotating part with the DC, there's nothing to it. I mean, you just put the rotor on, you spin it, and it does it by itself. There's no special code. There's no special pulse. There's no special, except itself, which is very special. I find it one of the most intriguing aspects of nature. Because, I mean, this will happen virtually any stator rotor combination you do where they're both free to spin. And that's the whole key. They can't be tethered down in any way. So I apologize again earlier for having to break the stream for a minute. I had a phone call I needed to get, and of course I take the video with my phone, so I had to pause for a moment. If you heard me, I'm trying to get the State Farm app. If there's more than one, I don't even know if there's more than one. I haven't looked. But we're gonna sort that out later this evening. Oh, yeah, I probably shouldn't have said that. Anyway, I'm saving some money, so I'm happy. It's an app on my phone. I mean, I'm not trying to do that, honestly. I mean, if they want me to do that, I'll do that for them, but my apologies again, sincerely. All right. I think that's going to be a wrap for today, though. I think 2.5 hours pretty much is enough to demonstrate this. It's been on the last 3 streams, maybe 4. I hope that, yeah, that's getting hot. That regulator for the light is really burning up. So I'll have to work with this again later. It's, yeah, that's hot. That is really hot. So I say that's a win-win situation. We're gonna try and make it smaller though. You might run with a 2N2222 transistor in the next build. Try and make it like that big. Because you can spin it like that. So cool. And this place will continue to evolve and get cleaner, and some days will be not so clean. But I think it's 100% better than it was just one stream ago. 100% better. We're looking for 200 or 300% though. We'll have our easels in the back here with either the latest painting or the latest diagram of a pulse motor, them being, presented. I don't know. We'll see what comes in the future. I mean, this seems to be a pinnacle of design for me. I mean, I am not an engineer. I have no schooling at all in engineering. I have no CAD education. That's why I use Tinkercad, because they have the shapes predefined for me. All I have to do is resize them, reshape them. It's good for me. The only problem is you got to eyeball a few things with Tinkercad. I mean, you can use the measurement tool, and that helps out a lot. But I'm pretty sure. I mean, even this one, it looks pretty freaking solid, and this is probably one of the more solid ones that I built. But these holes, yeah, this was a lot of going back and forth and switching between millimeters and inches and all that stuff to make this right. It's a lot of going back and forth with that stuff. But thank you. I really appreciate everybody coming in. Have a great day. Please subscribe. Bye now. Well, let me give you a quick rundown as I close out here. Get an aerial view. So that's a solidified shaft, 250 turns on each coil, one phonomic reed switch, so two 12-volt batteries. The reed switch is encased in this metal right here. Indicator light is on the front, so when the switch is closed, the light will turn on and energy will flow through, so the light will turn on. You need about 3 volts to make that work. Yeah, so that's the stator. Pretty cool. We're probably gonna, we might even like make our top this big to start, to see if we can make it. And so we'll get it on the ground, we'll spin it like this. So, get it? Like this. We might even like sharpen the tip so it's more of a point. We'll encase it with some coils, a reed switch, and voila. Put a battery in there. We'll probably put 2 batteries in there to balance it out, like 2 9-volts. But yeah, I mean, that's just utilizing what I already have. So, all right, peace out. Have a great day. Please subscribe. Bye now.